Welcome, everyone. I'm Alex Nada, CTO at Noble9, and today we're doing a webinar about EKG. EKG stands for Essential Kubernetes Gauges, and it is a set of prefab service level objectives for Kubernetes. I'll give you an overview of why we built it, what it consists of, how you can use it, how you can get started, and also how you can contribute if you're interested in getting involved with prefab SLOs as a part of OpenSLO in open source. So I'll start just by describing the original problem statement here. Kubernetes is a really interesting hosting platform, okay? Like many things that evolved in a cloud and cloud native environment and on the internet, it is designed to handle a small amount of failure and to tolerate a small amount of failure, a certain amount of failure. Having a managed control plane, like, for example, EKS, but also other managed control planes offered by a bunch of providers. I could name GKE on GCP or AKS on Azure. The managed control planes simplify a lot of the management of Kubernetes, but still the cluster stack can get complex. And the surrounding environment around our Kubernetes clusters is often also complex with a lot of multi-region situations, hybrid situations, sometimes multi-cloud situations. What we're looking to do with EKG is to create better SLOs on the platform itself, that is on the hosting platform of Kubernetes and what we can see from Kubernetes. The opportunity we have here is that Kubernetes clusters are similar to each other, right? This is a specific application that happens to do container orchestration in a cluster that we can make some reasonable assumptions about. And if we allow tuning knobs so that users of these SLOs can adjust the parameters to their specific situation, we actually have a good chance of governing or goal setting on Kubernetes using prefab SLOs. I won't go into a bunch of detail about why we would use service level objectives here. I'm kind of assuming that folks that are interested in this topic probably have some knowledge already about SLOs. You might be users of Noble9 or another product that offers SLOs. I'll just mention this really briefly. What do SLOs do? They allow us to define targets. It's essentially goal setting. And we can make those goals centric to the customers and to reliability and performance targets. So in other words, we're able to define the bounds that we want our systems to stay within and make sure that they stay there and alert us and tell us if they don't. Next, it allows us to get ahead of problems and filter the noise. These things just make a better alerting mousetrap and a better reporting mousetrap for operational problems. Third, this works on all different kinds of business verticals, all different kinds of workflows. It's a generalized technique for goal setting that works especially well with telemetry systems. And fourth, it allows us to find new kinds of efficiencies through automation. At scale, if you're running a ton of stuff, there's no substitute to having SLOs to help you govern that, okay? If you want to learn more, you can hit up our website, noble9.com, or many of our other educational resources, and we'll be sharing some of those during this session. What were we really looking to do with EKG? Well, what we really wish we had specifically for Kubernetes clusters is something like a check engine light. I'm not trying to build something that gives us root cause analysis, automatically detects problems and things like that. I'm really trying to provide something that draws our attention when something is wrong. And it should have a limited number of categories, like maybe these things. Hey man, something's wrong with your battery or your oil, or what is the next one? Your braking system. Something's wrong with your Kubernetes cluster. Let's go look at it, okay? Additional research is available in a variety of places, but the idea behind these SLOs is that we're just going to tell you whether your cluster is green or red or yellow. How we did that is we built some prefab or pre-built SLOs for Kubernetes. The first version of EKG, the version that's live right now, and I'm talking in April of 2023, is targets specifically EKS, which is the AWS flavor of a managed Kubernetes control plane. We try to make it as easy as possible to set up, and we try to make it as adjustable to your individual situation as possible. And by individual situation, I mean, look, we run a lot of different clusters. We run a lot of clusters in production, but also in non-production environments, all the way down to something, maybe aimed at an individual developer, QA activities, testing activities, et cetera. And all of those clusters have different expected behavior and different targets for reliability. Using EKG, we can tweak some, I'll call them the knobs, make some adjustments to these SLOs that allow them to be used in a wide variety of situations. How do we make it easy to set up? EKG is all Terraform in this version. It's Terraform and it's Prometheus based. If you don't have an existing Prometheus, EKG will stand up an Amazon managed Prometheus for you. And included with it are what we call electrodes of the EKG, which are essentially things that run in the cluster. These are proven open source components. We didn't create any of these ourselves. We sort of picked the ones that were most relevant to the task at hand of providing this kind of check engine light for your cluster. EKG can install those in your cluster, or you can use your own distribution if you already have metrics from that componentry. And here's a high-level diagram at a glance. Here's your cluster. As I mentioned, EKS is the one we're targeting now. We're very quickly bringing this to additional flavors of Kubernetes because the SLOs themselves are portable. The electrodes, specific instrumentation running inside the cluster. Amazon managed Prometheus or another Prometheus of your choice. You can bring your own Prometheus. Incidentally, in the EKS version of EKG, this arrow is provided by Amazon Distro for OpenTelemetry, which we colloquially refer to as ADOT, which basically can scrape the PROM endpoints of the electrodes, plumb that data into managed Prometheus. Then Noble9 data source has a connector stood up by Terraform that queries that Prometheus, and then the SLOs themselves. There's a handful of SLOs, and I'll dig into them a bit so you get an idea of what it is we're measuring and why we're measuring that. EKG can stand all of this up via Terraform in an empty cluster, or like I said, if there are pieces of it you want to use, it's modularized, and you can use individual Terraform modules to pick and choose what it is that you'd like, that you need in order to run these SLOs. Once you have those SLOs running, what that allows you to do is to set quantitative goals for how you want that cluster to behave. It gives you a version of shared reliability data that you can share with other stakeholders. For example, if you're a platform engineer that's supporting some dev teams, some production teams, some product teams, some business stakeholders, perhaps some customer stakeholders, you can use this shared reliability data to talk about and to manage the reliability of those clusters jointly with those stakeholders and give visibility to your stakeholders. What is it based on? At a high level, there are 4 things that we're trying to measure. You'll see I actually have 5 categories when I get in there because one of them is kind of an overall readiness of the cluster. But at a high level, what we're trying to measure is my control plane healthy? Is it performing well? Is it available? Is it performing within the parameters that I've set as requirements? Next, is the cluster healthy, which also includes the nodes in the cluster, which in an EKS context, for example, are EC2 nodes running in a VPC and managed by EKS. How are they doing? Third is a measurement of workload health. So one advantage that we have with Kubernetes over some other hosting options is that Kubernetes actually has quite a bit of insight about what's running inside the cluster. And that allows us to set certain nominative parameters or boundaries around what we expect the workload to be doing. And we have some SLOs around that. And then finally, cost efficiency. Cost efficiency is an area where we're going to be making some future investments as well, but right now we're mainly looking at overhead. Is the cluster actually being used? Is it oversubscribed? Is it undersubscribed? And as it scales, as it goes through whatever workload scaling or infrastructure scaling that's configured in it, is it within the bounds that we set for it? So let me give you an example. I'll show you what some of these things look like in Noble 9, and I'll show you the EKG modules themselves. Actually, let me just mention the EKG code repo itself. It's a public repo, Noble 9/EKG. You can see this is a mostly Terraform repo. And there's quite a bit of documentation in here that can walk you through this, describes what the thing actually installs, how to get it running in, let's say, a fresh EKS cluster if you want to kick the tires on it, and how you can use it and configure it. We also have in there a detailed explanation of what the SLOs do, which I won't be reading through this, but this will tell you why we define the SLOs we did, how to use them, how to reconfigure them and tweak them to your needs. And I'll spend some time explaining that in the context of how they look inside of Noble 9. What I did here was I installed the EKG on a small test cluster. It's not really running anything. So this is kind of similar to what you might see if you spun the thing up. We do run this on our test and production environments, and we use it to manage our clusters. It's not the only thing that we have running on our clusters. We have lots of other SLOs on our application and other aspects of our cluster. But like I said, EKG gives us that basic, is the cluster happy right now? Check engine light. But this cluster I'm showing you today is just, it's a tiny little cluster that's not doing much. So you can see I have, at a high level, I have 5 SLOs. Some of them have multiple objectives in them. And I'll walk you through these and just explain what our motivation was and why we picked or selected the SLOs we did. I say selected because I didn't make most of these up from whole cloth, okay? We work with a lot of customers, many of whom are hosting in some kind of Kubernetes, often EKS, sometimes some other kind of Kubernetes. And we have the advantage that we can talk to them about their SLOs and kind of look at what they've defined, and also look at which of those SLOs they like most, so they get a lot of benefit from. And many of these are inspired by customer SLOs that those customers liked, or that we liked in some aspect of what they created or that we helped them create to address a specific problem. This first one is called cluster readiness. In Noble 9, if you're not familiar with Noble 9, what you'll see is that we have a service level indicator. So we're charting the data that comes in. This data is from a Prometheus query. This is using a framework called Kubernetes. Kubernetes is an open source Kubernetes operator that essentially provides Kubernetes synthetics. So it can do a variety of different things, but out of the box, one of the things it does that I'm zeroing in on here is that it can launch deployments. And it can launch deployments on an intermittent basis as a synthetic to test whether you're able to launch a deployment right now. It can also do daemon sets. It can do a bunch of different kinds of checks. This is doing using the Kubernetes check called deployment, okay? And I'm tracking 2 things about it. The one is how long did it take, the duration in seconds to launch that deployment? And the second one is, was it successful? And if I get a failure, that will eat some of my error budget. Okay. And then on those, I've set some thresholds by default. The first one for pod start lag, I call it, is 99% of the time, or 99% of the instances, really, it should be able to launch those pods of that deployment in under 180 seconds. And if it takes longer, then it will burn some air budget. Okay, and then pod start failure should be successful every single time. So if those pods of that deployment fail to start for some reason within a certain amount of time, then it will give us a 0, and that again will burn some air budget. And let's see how this guy's doing right now. You can see actually this one is underwater. If I look back, it was doing fine. What was that? 4 weeks ago, it was in the green. It slowed down. I honestly, this is because I'm testing stuff in my cluster. I'm messing around in my test cluster, working on EKG stuff or other prefab SLO stuff, and I probably broke something that or filled the cluster temporarily such that it couldn't launch any pods. Okay, but if I zoom in on here, I think you can see a little bit how Noble 9 SLOs operate and why they would be useful for this kind of thing. And I'll just zoom in on this little spot right here where you can see there was a violation. That pink dotted line represents my threshold of 180 seconds. And you can see in places where this latency violated that threshold, we had a slight drop in reliability. So during this plateau or this spike right here, we went from 97.67% adherence down to 97.59% adherence to this SLO. Our target again is 99. Now, if I know that my cluster will start a little slower, or my cluster will be out, might expect it to not perform that well more than the 1% of the time that's allowable here, I can adjust that, okay? And I'll give you a little more example when I talk about kind of how the Terraform side works to show you how we adjust that inside of EKG, but we've centralized that configuration so you can edit all of the adjustments for all of these SLOs in one central point per cluster in Terraform. So the basic idea behind cluster readiness is it provides a measure of end-to-end usage of the cluster. There could be a variety of things wrong with the cluster. Obviously, this isn't testing whether every node is happy, whether your memory headroom is where you want it to be, et cetera. But it gives you an indication of, can I use the cluster today, right? Can I launch a new workload? Does it run? Does it come up in a reasonable amount of time in a way that, you can tweak that to your particular cluster behavior and your requirements. Let me talk about the next one. The next one is control plane health. Control plane health is inspired by one of the SLOs that's published by a Kubernetes SIG. It's not precisely exactly the same as they define it, partly because we wanted to keep it very simple, and partly because we're just observing how EKS normally behaves. But what this is doing is it's looking at, so this is using metric server metrics that, again, in EKG are actually plumbed out by ADOT, right? But other metrics plumbing into Prometheus would generally include these metrics. This is looking at the total number of requests that were made and how many completed or either didn't complete or completed badly, okay? So I'm looking at 5XX responses plus terminations. What's the other piece that's in here? Yeah, terminations plus 5XX. Basically, how often is your control plane responding badly? And there's a second objective in here, which is response time. And in this case, I'm looking for mutating requests, so post, put, patch, delete, and looking at how many of them complete in less than a second, which is similar to how that's defined, like I said, in that SLO that's published by the SIG. This one on my little cluster is completely green. Personally, I have yet to break EKS. I do have some customers who have broken EKS on occasion, or occasionally. I've heard of a couple different kinds of failure modes. It's possible to overwhelm probably any managed Kubernetes. You probably could overwhelm it if you do the right thing, or the wrong thing, I should say. And also, it's possible to make this fail if you're using a lot of add-ons, or even just a few add-ons, and you get them wrong. I imagine probably mostly everybody is using Kubernetes add-ons. At the very least, you must be using core DNS, but you're probably using a bunch of other stuff. It's possible to break the control plane, and if that's the type of problem you're having, you're going to want to know that pretty quickly. So that's how we set this one up for monitoring control plane. Basic measure of error rate and a measure of response time. Then that brings me to memory headroom. Memory headroom is it's kind of a standard thing you might measure. It might be a little bit creative to consider measuring headroom the way that we're measuring it here, and also to measure memory headroom across the cluster as a whole. Okay, you may have memory issues on any individual node. You might also look at memory management of individual or other resource management of anything that you're deploying into Kubernetes. You might look at it at the deployment level, at the pod level. We do have SLOs on those things that are specific to the workload. But in this case, what we're trying to measure is my memory usage in this cluster within the bounds that I want for it? Another way to look at it would be, let's make sure that I'm not sort of overly bin packed. Okay, I could pack stuff in there really tight, or by luck, as things, during cross upgrades or relocations, things get packed in a little too tight. And I may have a situation where I don't have enough sort of breathing room or moving room to go through normal cluster operations, like maybe an upgrade, or maybe maybe I need to replace a node pool, or move some, or even simply an application deploy that moves something around. That's the idea behind insufficient headroom. Both of these queries are the same for both insufficient headroom and memory underutilized. Again, this is a little bit creative, because basically what we're doing here is we're summing resident memory, and we're dividing by allocatable memory. You might say, wow, that's really imprecise. That's really strange. And it is a little bit creative. However, this is a very pragmatic metric. In my default settings for this, you can see that insufficient headroom is above 90% utilization, and underutilized is below 70% utilization. And so I'm kind of assuming that for many workloads, you want to run your cluster somewhere between 70% memory full and 90% memory full. But that can vary really widely. That can vary really widely by workload. For example, some workloads have spiky memory. They may actively launch pods during certain circumstances and eat up a lot more memory. And so you need to maintain a lot of extra headroom in your cluster. In other cases, you might have a process that, for example, does a lot of file I/O. And across your hosts, maybe you want to make sure that those files get cached. And that's not going to show up as resident memory, right? That's file cache. So maybe you want to set your headroom requirement to be a lot lower than 90% full. And maybe you even want to set your utilized, that is utilized in resident memory, a lot lower than this as well, to allow for that breathing space. What we find is that for a lot of clusters in the wild, using this kind of metric and setting those two bounds on your memory utilization can be really useful to spot problems. Okay, sometimes you have a problem where you've accidentally resized, removed, or sometimes added node pools, different classes of machines. Maybe the application development team that's working on it has moved some workload around. They moved it into another namespace, or something has changed in the cluster. And so this is kind of a general, is the engine humming from the memory perspective, right? If you look at mine right now, you'll see that per my default setting, my EKG is telling me that I'm drastically underutilized in memory. And that's because this is a little test cluster and I don't happen to be doing anything in there right now. So in fact, yeah, it is my memory is underutilized because this cluster isn't really running any workload other than Kubernetes Health and the other telemetry in here. So that's valid. If this were running a production workload, I would tune these in a way that they can they can report properly and make sure that I stay within the bounds that I set. But it does require some consideration about what your workload does and what your workload requires. So moving on, the next one is node health. Node health is looking at two separate things. We have node not ready. Node ready is based on kube state metrics. And I'm just looking at, is the node, literally is the node ready? And my other metric here, node problem detected, is based on node problem detector. And that literally is just wrapping node problem detector with, wrapping the problem counter from node problem detector. Node problem detector handles a bunch of different stuff. If this reports, then it has detected one of the wide variety of problems that probably mean you have at least a bad node, and it may or may not fall out of the ready status, which is why we wrap with both of these things. Node not ready, I'm looking to stay 0, and node problem detected, I'm looking to stay less than 1, which kind of also means 0, but these are both adjustable knobs. So let's say that you're running a cluster with maybe a couple thousand nodes in it of different types, a couple of different node pools. You may regularly see, let's say, a dud EC2 host, right? A dud node on occasion. The beauty of this SLO technique is that you should be able to tolerate a certain amount of those things. Hopefully you have some other alerting or process that heals those in some way, whether it's like an auto healing feature or something that somebody's manually cleaning up. And that's great. What you want to do is set this so that it can tolerate the amount that does happen to your clusters in the wild and make sure that it doesn't go way out of bounds. So this gives you a way of kind of adjusting that and zeroing that in. And then that brings me to workload health. Workload health has 3 metrics in it. The first one is, I want to make sure that I don't have a lot of pods, and this is all using kube state metrics. I want to make sure that I don't have a lot of pods that are in a pending state. I think you all know what this looks like. Pending state means it can't be scheduled, right? Something is wrong. It's short of resources, or there's something else wrong that's preventing that thing from running. In my current installation, that is failing. The reason is I'm not running a lot of other stuff, and Kubernetes Health creates a bunch of pods that say pending briefly. And so, if I were tuning this cluster to the current workload, which is little to no workload at all, I should tweak that. But really, I think for many workloads, this default setting of 99% of the time, no pods pending is probably a lot more normal for your cluster. The next one is not enough running. Whoops, sorry, those are out of order. Not enough running. I'm really just counting the average number that are in phase running. I do have a feature request from someone right now saying, really, I'd rather look at the I'd really rather look at deployments or maybe daemon sets and kind of look at the statuses of, larger pieces than pods. But this is literally counting running pods. And then the third one is, do I have any pods that are in failed or unknown status? And we can see occasionally a passing unknown status. Failed should generally not happen in a healthy cluster unless, like I was saying, there's some problem with the node. That should be a pretty rare event, but it can happen on occasion. So again, as you can see in my tiny test cluster, it tells me I'm not running enough. That's true. I'm not running much other than, EKG itself, and it looks like an underutilized cluster, not only from memory, but also from looking at what's running in the cluster. I don't have any pods in a bad state, which is good. That's expected. And then it is also telling me that I have too many pods pending, which, like I said, is because I'm not running much else. And Kubernetes Health is launching a bunch of pending pods. So I've let that go. I want to make sure you can see what Noble 9 looks like when the lights light up, and you can see some of the things we present here, like the burn rate, the air budget remaining stated as a time, and that you can see what a reliability burn down chart would look like. But it's not a problem for my little demo cluster for these to be running that way. What I would do if this were a production cluster or even a dev or test cluster is I would tweak the settings of EKG, change the boundaries to stay green. And the ideal scenario that I'd like to see for an SLO is, I'll go back to this one because I know this one was bouncing up and down, and maybe I can show you kind of a longer view. I would like to see something that looks more like this. I'd like to see that my SLO, it's okay if it starts at 100%. It doesn't have to start at 100%. I'd like to see it eat some air budget from time to time. That's how I know that it's actually measuring something. If it stays green dial tone the entire time, it probably needs to be tuned. And I want it to sometimes almost run out of budget, but I'd rather it not cross the line. If it crosses into the red and I didn't actually have any kind of outage or problem, then maybe I need to reevaluate my threshold and loosen it a little. And like I said, if it's always green dial tone and it never really burns any budget at all, or only burns a tiny amount of budget, then I probably want to reevaluate it and see if I should tighten the target and threshold for that SLO. You can have a totally valid situation where it's 100% all the time. Maybe it's just a very reliable service, or it does a very small job and it hasn't had any problems lately, and that's fine. But most good SLOs do burn budget as they're being used. Okay. So in EKG, as I mentioned, EKG is a Terraform project. And so I have it set up in here. And I think if I run a Terraform plan now, I believe I'm up to date. But one of the things I can show you here is that we do have inside of EKG, we have a central configuration for the entire cluster. So here you can see I'm setting a region, I'm setting my cluster ID, I have my organization ID. I have some credentials that are actually set as shell variables using the Terraform mechanism for that, because those contain secrets. And then I have all these settings here, okay, which are really just Terraform variables. But you can see in here are the parameters I can adjust on my cluster readiness SLO. If mine doesn't start within 180 seconds and I need to give it more time, or maybe I should actually tweak this, because it looks like in my cluster readiness, I'm frequently, let me go back to the current time window. I'm frequently enough exceeding 180 seconds that maybe 180 seconds was just a little too aggressive for this particular cluster. Incidentally, we have another feature called SLI Analyzer that would allow me to slice and dice this data, even get a histogram on this data, and look at where I should set my target and threshold. But in lieu of that, I'm just going to set it a little bit higher. I'm going to set it to 250. Let's just say 250. I'm going to leave the target the same, 99% adherence, but I'm going to say I'm okay with it taking, let's say 240. I'm okay with it taking a full 4 minutes to launch that deployment check. I'm fine with that. Meanwhile, I would like to adjust my memory headroom. I'd like to say, let's say per my example of maybe this thing does a lot of file IO, right? I never want it to be more than 60% utilized. So I want my memory headroom to be 60%. And my normal way of running it is maybe only 40% allocated. I'll allow it to spike memory. I'll leave a lot of room for caching a bunch of file IO, right? And I can now Terraform plan this and apply it and manage it centrally. And this is one of the great things about, if you're Terraform users, especially, of managing this in a central way, is that we can make something that is essentially like this Terraform distribution of EKG is, on the one hand, an installer set, and on the other hand, it's our way of managing a central configuration there, and then applying that to a variety of clusters. I know many of you are probably running some hundreds or thousands of clusters, each of which has some hundreds or thousands of nodes in it. And that's exactly the type of environment that we have designed this for. You should be able to run this that way. We have a lot of infrastructure as code support in Noble 9, not just Terraform. We also have a Kubernetes-inspired YAML called SLO-CTL with its own YAML format. And we took a version of that YAML format and we open sourced it as OpenSLO. OpenSLO is starting to get some traction in the space. And I do want to mention, we're making a big push now to, within the context of OpenSLO, to add more prefab stuff. Kubernetes is the first version of that, okay? It was inspired a bit by my colleague, Alex Hidalgo, who said, if I could go back and do SLOs from scratch, I would love to set SLOs on the power circuit in the data center racks and give that SLO to my hardware folks and ask them to set a hardware uptime SLO. Give that to the sysadmins and ask the sysadmins to set some operating system SLOs, right? And I was like, oh, that sounds like a great idea. That's a wonderful way to do it. But I don't buy power anymore. Not in our cloud hosting situations. I buy basically Kubernetes, right? Managed Kubernetes and nodes that are VMs. And so that's where we started there. But we're very quickly going to move up the stack. We're going to be defining prefab SLOs for other commonly used cloud services. So for example, cloud load balancers, storage products like object storage, but also maybe file system storage or block storage, managed database services, functions, all kinds of different stuff, okay? API gateway products, et cetera, across the different clouds. We're going to do that in a way that's reusable. We're going to open source it as part of OpenSLO. So if you would like to learn more, or even better, if you'd like to get involved with that, we're looking for help and for feedback. We can share with you the way to get involved. The best way to do that is to sign up for the OpenSLO Slack. We have a separate Slack instance for that, and we'll share that in the chat and in the follow-up materials from this session. In addition, we have an annual conference about SLOs called SLO Conf. This year it is May 15th. It runs over several days. We also have some local events, depending on where you live. We might be running a local event in your area and you can get involved that way. SLOconf is full of wonderful educational materials. This year, I noticed there's a bunch of really cool talks, including some really unique topics for the talks, all related to reliability management using surface level objectives. That's a really great resource. We also link to a lot of different stuff from our website, noble9.com. We have blog posts in there and we link out to a variety of places. We also have a methodology called SLO DLC, as in SLO development lifecycle, but also SLO downloadable content, where you can find just a ton of information to help you get started, help you run an SLO program, help you raise awareness in your organization if you find yourself in a situation where you're trying to show people how to use SLOs and the benefits of them. So let's go to questions. Can I answer any questions for folks? Cost angle. Okay, so as I mentioned when I was going through this presentation, we do mention cost efficiency in here. And we do have a cost efficiency. I would say cost efficiency is in our charter. Okay. Where are we going with that in the short term? There's two directions. The one is that separately, outside of EKG, we are making cost SLOs, like you might call them FinOps SLOs, especially for public cloud systems. And that involves a couple of additional data sources and some practices. Maybe there's a methodology there or some best practices or standard practices, maybe even some prefab SLOs to help you track your cloud spend. And you can set cost targets for workflows with, all the benefits of an SLO, like giving people some leeway. You can maybe stray outside of that cost without tripping all the bells, and as long as you bring it back in line. But within EKG, the other thing we're looking at adding to this, I mentioned what our electrodes were today. And in particular, today, as I mentioned, there are three main electrodes that we're installing there: CubeState metrics, node problem detector, and Kubernetes Healthy. And then also, ADOT goes and gets other stuff, including like metrics API stuff, right? C-advisor type metrics. What's missing from here is an actual first-class cost system. And so we're looking at Cube cost and the open core open cost as a short-term addition to this, so that we can ideally set cost targets for resource utilization directly for Kubernetes workloads. That's a feature request that we're working on now. It'll probably be out in the first half of this year, so in the next couple of months. But it's beyond, there are a couple things in line ahead of it. One of which is we're going to take these to a bunch of other, we have this in a separate repo here that's, like I said, a Terraform repo that you can use. It's open source, but we're trying to port this into other popular places where people are looking for reusable templates, such as the AWS Observability Accelerator, as well as EKS Blueprints, are both on our wish list in the short term. Then we're looking at taking it to other managed Kubernetes. So as I mentioned, this currently is very EKS centric, but the techniques and a lot of the code in here, including the SLOs themselves, they're not specific to Amazon's EKS. We can also use them with other managed Kubernetes. So we will be adding GKE and AKS. That's what we're planning now. We also have some ask about, hey, can I also use these in OpenShift? We're talking about and looking at OpenShift as a way, in order to address that as well. So cost is on the list. We're kind of juggling that feature request among all the other things. And if anybody has specific ideas or experience on setting SLOs, or really other kinds of cost monitoring inside of Kubernetes, please get in touch. I would love to have a conversation. Best way to do that is join the prefab Slack channel in the OpenSLO Slack. We'll make sure that the link goes out with the follow-up materials from this. Good. Okay. So yeah, I think that's it for now. Thanks everybody for coming, and hope to see you on the next one. And like I said, please don't hesitate to reach out on OpenSLO Slack or sign up for a Noble 9 trial. Reach out to us, hello@noble9.com if you have other questions or want to connect in some other way.